Welcome to the DIY Honda Garage channel. This presentation provides a comprehensive troubleshooting guide for the DTC P0404, which indicates an issue with the EGR valve circuit range or performance in Honda Accord models from 2012 to 2017. The focus is on diagnosing and repairing problems related to the exhaust gas recirculation EGR system, specifically the EGR valve and its associated circuits. Understanding how the EGR system works is essential, as it recirculates a portion of the exhaust gases back into the intake to reduce emissions and regulate engine performance. The guide covers diagnostic steps, component testing locations, and procedures to verify repairs, ensuring vehicle emissions compliance and optimal engine function. Proper troubleshooting can prevent unnecessary replacement parts or costly repairs by precisely identifying the fault source. This guide emphasizes step-by-step processes aligned with factory diagnostic procedures, including the use of Honda's HDS scan tool to interpret live data and diagnostic results. After completing all repairs or component replacements, perform a final verification to confirm the system functions correctly. Reconnect all electrical connectors, ensure no wiring damage remains, and exit the SCS mode using the Honda HDS scan tool. Then, reset the PCM, perform the idle learn procedure, and execute the EGR test again. Monitoring the OBD status for DTC P0404 during this final step is critical. Ideally, the status should indicate passed, showing the system is restoring normal operation. This comprehensive verification ensures that the repair has resolved the issue and that the vehicle complies with emissions regulations. Prevention starts with routine inspection and maintenance of the EGR system. Regularly checking the EGR valve and associated passages can prevent carbon buildup that leads to blockages and faulty readings. Cleaning these parts with throttle plate cleaner maintains unobstructed flow and sensor accuracy. Additionally, ensuring that the vehicle's PCM has the latest software updates can optimize EGR operation and diagnostics. Performing these preventive measures can significantly reduce the likelihood of P0404 codes recurring, enhance engine performance, and ensure compliance with emissions standards. Consistent maintenance contributes to vehicle longevity and reduces repair costs over time. In conclusion, troubleshooting the P0404 code involves a systematic approach that includes verifying the fault, checking wiring integrity, testing sensors and connectors, cleaning ports, and replacing defective parts. Using diagnostic tools like the Honda HDS scan system ensures accurate interpretation of results and guides appropriate repairs. Always confirm the repair effectiveness with tests and system status monitoring before concluding. Proper diagnosis and repairs not only fix the immediate problem, but also prevent future failures, ensuring the vehicle runs efficiently and emissions compliant. Staying methodical and adhering to manufacturer procedures is essential for effective resolution of DTC P0404 in Honda Accord models. Begin by confirming the presence of the DTC P0404 and reviewing freeze frame data and onboard snapshot data stored in the vehicle's ECU. This initial step is crucial because it provides context such as engine temperature, RPM, and operating modes at the time the fault was detected. Recording this data helps determine whether the issue was intermittent or persistent, guiding further diagnostic steps. Make sure the vehicle is in the correct test conditions as per the manufacturer's instructions, with the engine in on mode for system verification. Using Honda's HDS scan tool, clear any existing DTCs and then perform a controlled engine test, holding the engine at 3,000 RPM without load. Then, execute the EGR test to verify if the system passes or fails under current conditions. This process is essential to establish the initial fault status before proceeding with detailed component checks. In this step, turn the vehicle's ignition to off to safely disconnect the EGR valve's electrical connector, identified as the EGR 5P connector, located near the EGR valve. Using a multimeter, measure the resistance between test points 1 and 2 at the EGR valve side, specifically the terminals number 3 and number 4 of the connector. This resistance measurement assesses the internal circuit of the EGR valve's position sensor, which indicates the valve position to the ECU. If the resistance is 100 kiloohms or more, it suggests a faulty internal circuit, and the recommended action is to replace the EGR valve. Proper testing at this stage helps determine if the sensor's internal circuitry is functional or defective, critical for accurate EGR operation. Next, perform an internal circuit resistance test at the EGR valve itself. With the vehicle ignition still off, measure the resistance between test points 1 and 2 on the EGR valve, which correspond to terminals number 2 and number 4 of the connector. This test evaluates the internal wiring and sensor circuit integrity within the EGR valve. A resistance of 100 kiloohms or more indicates internal circuit failure, prompting the replacement of the EGR valve. If the resistance is below the specified threshold, it suggests the sensor wiring is intact and further electrical checks are needed. Validating the internal circuit resistance confirms whether the EGR valve's sensor assembly is functioning correctly or requires replacement. This step involves diagnosing potential open circuits in the PG line, which is the signal wire from the EGR valve to the ECU. With the vehicle in off mode and connector disconnected, measure continuity between test point 1, which is terminal number 1 on the EGR valve connector, black wire, and ground. Continuity indicates the wire is intact, whereas no continuity signifies an open circuit. An open circuit in the PG wire can cause incorrect EGR position readings, triggering the P0404 code. Repairing any open in this wire ensures proper communication between the EGR valve and the ECU, restoring normal EGR operation. This step is fundamental to rule out wiring issues before proceeding with more complex diagnostics. In this step, test for a short circuit on the EGR line, which connects the ECU to the EGR valve. Use the HDS scan tool to jumper or simulate EGR signals on the SCS line to check for abnormal conditions. Then, with the vehicle's ignition in off, disconnect the PCM connector C at pin 13, PUR wire. Measure continuity between this pin and the body ground. If there is continuity, it suggests a short circuit causing interference or incorrect signals, necessitating wiring repair or replacement. If there is no continuity, then the wiring is intact and the fault originates elsewhere. Identifying shorts in this line is crucial because a short can cause erratic EGR valve operation and false DTC triggers. This step further verifies the integrity of the EGR wiring. With all relevant connectors disconnected, measure the resistance between test point 1 at the EGR valve side, terminal number 5, PUR wire, and terminal number 13, PUR wire at the PCM connector C. The goal is to confirm that the wire connecting the ECU and EGR valve is continuous and free of open circuits. If there is continuity, the wiring is sound and the fault may be internal to components. If not, an open wire segment must be repaired. Consistent wiring testing ensures a reliable signal path, which is essential for correct EGR function and diagnostic accuracy. Cleaning the EGR port and passage ensures unobstructed flow of exhaust gases back into the intake manifold. Remove the EGR valve and inspect the port inside the intake manifold where the EGR gases enter. Use throttle plate cleaner to thoroughly clean the port and passage inside the EGR valve itself to remove carbon buildup or blockages. Reinstall the EGR valve securely. Reconnect all electrical connectors and then reinitialize the system. After reinstalling, perform a PCM reset using the HDS, followed by the idle learn procedure. Running the EGR test after cleaning confirms if the passage blockage was causing false P0404 codes or performance issues, restoring proper EGR operation. In this diagnostic step, substitute the EGR valve with a known good unit to determine if the original valve was faulty. Reconnect to the EGR 5P connector, then set the vehicle to on and reset the PCM using the HDS. Follow the idle learn procedure to allow the ECU to adapt to the new component. Then, run the EGR test to verify system performance. If the code clears and the test passes, it confirms the original EGR valve was defective. If not, or if the problem persists, further diagnosis may involve PCM updates or replacement. This substitution test helps pinpoint component failures and ensures the system operates within specifications. Please like and subscribe to the channel. See you next time!